This is a recap of learning for Unit 9, Lesson 2. And in this unit, it's a two-part unit. The first part is how do we graph sine functions? And so we're going to start off with the very parent sine function. So in your notes, please write y equals the sine of x. Now what I want you to recognize that in front there's a positive one we can't see, and in between the sine and the x value is also a positive one. When we graph this, there's a few things that we're going to identify. I want you to look right now in front of you, whether you are here with me or you are watching this video, and I want you to go and put start at this position. Please write the word start. And then this is going to be step 1. This is going to be step 2. Down here is step 3. And back over here we are finishing at step 4. In addition to that, I want you to come up at top and we're going to write down an acronym. Just like there is channels on TV like ABC, NBC, Fox, there's CBS. CBS is going to be our acronym that tells us we are always going to identify the first value in an ordered pair as the cosine value, and the second value is going to be the sine value. We are used to thinking of these as x and y's, and it works much the same, but we are now going to be actually taking the cosine, and we'll learn more about that ratio at a little bit later time. We're going to take the cosine of an angle, that's the first value, and then the sine of an angle. Again, we are going to touch back on that ratio and what they mean at a later time. Let's get started. Okay, so we are going to graph this function. All of our functions are going to be a 4 count. So when we work with sine and cosine in this particular lesson, which is lesson 2 of unit 9, we're going to do 4 counts. We're going to evenly space these apart. 1, 2, 3, and 4. That's one cycle. That's one cycle. And so you're wondering, like, how do I graph this? So I'm graphing sine. I'm going to come up here. I recognize sine is the second value. So when I start, this is the starting line, sine is the second value. It's at 0. I'm going to go to step 1. Sine it goes to a value of 1. So I'm going to go right now over to step 1 and up 1. I'm going to go to step 2. The sine value is the second value, and it's at 0. I'm going to go to step 3. Sine is the second value. It's down to -1. And step 4, sine is the second value, and it's at 0. Now, when you connect these, you're not going to make a sharp point. This is going to be a curve. This is one cycle. This is one cycle. And so we call one cycle either one of 2 words, depending on who the author of your math is. It's either going to be referred to as the period length or simply abbreviated as the period. And that means how long is one cycle. All right, so the next is we're going to use, and just for abbreviation, I'm going to use the word period. I'm going to use the word x scale, and we're going to talk about those values, and we're going to talk about the word amplitude. Amplitude describes a distance, and that distance is from this midline, which cuts this shape of this wave curve in half. This distance will always be equal to this distance. We know distance is a positive value. So what is this distance? From the midline, I'm going up 1 or down 1. It's a distance of 1. So I know visually that the amplitude is 1. Is there another way that we can identify this without having to graph it? There is. We take whatever value is directly in front of the function, and I take the absolute value of that. So the absolute value of +1 is 1. Sometimes there's this misunderstanding that we just change a sign. That's not the case. We make it positive. Whoa, messed that up. All right, so period, what is this length? Well, how can we do it? Well, a couple things. Visually, we can see that one cycle around is a distance of 2 pi in terms of radians. But algebraically, how could I have done that? Well, algebraically, for both sine and cosine, not tangent, but for both sine and cosine, you're going to take 2 pi and you're going to divide by what's called the b value. The b value is whatever value is directly in between the sine and the x. So directly in between sine and x is a 1. That means for this function, 2x divided by 1 is simply 2x. So here's algebraically how I did it, and here's visually on a graph. Last, x scale is this distance. This is equally spread out apart. How do I get from one step to the next? Because they're all going to be equal spaced out. Well, we can see that there's 4 steps. Remember, here's your starting point. Step 1, 2, 3, and 4, equally spaced out. You're going to take whatever your x scale is, and you're going to divide it by 4. So when you divide fractions, you're going to take 2 pi over 1, take division, turn it into multiplying, and I end up with 2 pi over 4, which reduces down in this case to 1 pi over 2. If you've not grabbed a calculator, please run over and grab a calculator. So the x scale is 1 pi over 2. I need you to all have a calculator in front of you. Okay, we are now going to label each one of these 4 steps. We're going to be required to do 2 cycles to the right and 1 cycle to the left. I'm going to show you on a calculator how do we quickly do this. Once we figure out what the x scale is, I'm going to eliminate the pi symbol for the purpose of plugging it in. Please watch. Okay, first step. That's why I put a 1 in. First step, I'm going to take it times the 1/2. I'm going to omit the pi. That means I'm not going to put the pi symbol in, and I press enter. If I get a decimal, I'm going to hit math, fraction, enter, enter. Okay, this is going to be, at first step is going to be 1/2 and throw a pi on top. Okay, here's my second step. That's why I put a 2 down. I'm taking it times the 1/2 that we see over here as the x scale. Again, if I get a decimal, then I hit math, fraction, enter, enter to turn it back into a rational value or a fraction value. Okay, third step, taking it times 1/2. There's my decimal. I turn it back into 3/2 pi. Fourth step, you can see what I'm doing here, and so on. Now, we're going to have to go 2 cycles to the right. So this is 4 steps, 5, 6, 7, 8. Okay, here we go, 5th. So I'm going to go quickly through this, and you guys get the point of how I'm doing this here. So I'm just going to go through and do it quickly. And then the next thing we're going to do is we need to continue this cycle. So this is 1 up, and it follows this pattern continuously. Remember that we are curving at the top here. It's not going to be rigid like a V. And then that arrow says it continues. We're also going to do 1 cycle, and this is required, to the left. So the easy part here is when I do the 1 cycle to the left, I get to copy these down and include the negatives. So negative 1/2 pi, negative 1 pi, negative 3/2 pi, and negative 2 pi. The last question they're going to ask is 2 cycles to the right is how far? And the answer would be, on this graph, the maximum x value we see is 4 pi. And then 1 cycle to the left, the minimum on this graph, the minimum x value that we see is going to be negative 2 pi. Now, it's continuous, but on our particular graph, that's what it is. Let's get started. Okay, this is example number 2, and again, we're recapping what you previously learned in the last videos. The first thing I'm going to do is I'm going to identify the amplitude. The amplitude, algebraically, is we take whatever value is directly in front of the function. It happens to be a hidden 1. The absolute value of 1 is 1. That means from this midline, I'm going to go up 1 and down 1. This is my midline, and so I'm going to take a highlighter. And remember that this midline is going to cut that wave curve evenly in half. All right, what is the period length? That means what is the length of 1 cycle? All right, I'm going to take 2 pi, and I'm going to divide by this b value. So I'm going to take 2 pi, or you can write 2 pi over 1, and I'm going to divide by the b value. In this case, the b value, which is always directly in between the sign or the function and the x, is a 5. So here we go. We have 2 pi divided by 5 over 1. Well, that's, remember, we keep, and we change, and we flip. I end up with 2 pi over 5. This is the length of 1 cycle. So I'm going to come over here and write 2 pi over 5. That's 1 cycle. That means to make this wave curve takes a distance, a horizontal distance of 2 pi over 5. How do I figure out the x scale? Whatever our period length is, and maybe you want to write this down, I'm going to abbreviate. We take our period length and we always divide it by 4 to figure out the x scale. So my period length is 2 pi over 5, so 2 pi over 5. And now I'm going to divide this by 4. Why? Because there's 4 equal steps in both sine and cosine. 1, 2, 3, 4. Starting 1, 2, 3, and 4. Okay, I'm going to divide this by 4. Okay, remember, same thing. We keep, change, and we flip, and end up with 2 pi over 20, which reduces to 1 pi over 10. Okay, so this is 1 pi over 10. Now I'm going to start, and then I'm going to ask those that are with me in person to race through this as quickly as possible. Remember, we are going to have to do 2 cycles to the right. So here we go. How would we start by doing this? We're going to omit the pi symbol when I plug it in. So here is the first step, and then if it's a decimal, I go back and I hit it, right? Math, fraction, enter, enter. Now I go to the second one. So I go the second times that x scale. If I get a decimal, I hit it again. So this is 1 pi over 5. You're understanding, hopefully. I go back to that x scale value and continue. Please, at this time, I want you to do 8 steps to the right and 4 steps to the left. All right, so I've gone ahead using that calculator. Again, you're omitting the pi symbol when you're simplifying it. And then this represents, again, this is step 8 times that x scale, right? If I went up previously, just so you're seeing, in case this confuses you, this is step 7 times the x scale and so on. And then I'm reducing it. All right, it is time to graph. Here we go. I'm working with the sine curve. And so whatever value is out front, by the way, we're going to multiply times whatever my output is here. So I'm going to start here. The sine value at the starting point is 0. 0 times 1 is 0. Let's go to step 1. Step 1, the output value is 1. 1 times 1, the value up front here, is 1. Go to step 2. The sine output value, sine is the second value, is 0. 0 times whatever value is in front here, which is 1. So 0 times 1 is 0. Go to step 3. We have an output value of negative 1. Negative 1 times 1 is negative 1. And then finally, we have 0 again. 0 times 1 is 0. Once you've completed one cycle, you're just going to mimic it. So I'm going up 1, back down 1, and back. And then make sure that you have this arrow that says it continues to go. So it's a continuous cycle right now. Unless they limited the input, it's a continuous cycle to the left and to the right. When you look in your homework and you see the word x max and x minimum, they're just saying, because the direction said do 2 cycles to the right and 1 cycle to the left. They're saying how far does it go out after 2 cycles? It'd be 4 pi over 5. How far does it go to the left? It would be negative, these all had to have a negative, negative 2 pi over 5. We're looking at example number 3 at this time, example number 3. All right, what are we doing for example number 3? So for example number 3, the first thing I'm going to do is I'm going to look here at the amplitude. So I'm taking whatever value is in front of the function, which is negative 2/3, and I'm taking the absolute value of that. That means make it positive. So the amplitude, that means the distance above or below the midline, is going to be 2/3. So I'm coming to my midline. And I know that we're going to have a 4-step here. Sine, cosine have our 4 steps. 1, 2, 3, and 4. I know I'm going to go as high as 2/3, and I'm going to go as low as 2/3. That's based on my amplitude. Next is the period. I'm taking 2 pi, and I'm going to divide it by 3. 2 pi divided by whatever value is directly in between the sine and the x. So 2 pi over 1, we're going to stay, change, and flip. That gives us 2 pi over 3. So 2/3 pi is going to be this period. That means after 4 steps, the period is always going to align for sine and cosine. After 4 steps, we have a horizontal length of 2 pi over 3. I've done this motion. We end at 2 pi over 3. How do I figure out the x scale? I take whatever that period is, and I'm always going to divide it by 4. Same thing. I'm going to go with stay, change, flip. So I have 2 pi over 12. Well, 2 pi over 12, that reduces to 1 pi over 6. 1 pi over 6. That means each step here, between each step, has a horizontal distance of 1 pi over 6. Now, here's where I want you to use the calculator as your guide. How do I come up with these others? So this is step 1, 2, 3, 4. That's 1 cycle. And then 5, 6, 7, 8, I've finished 2 cycles. So here's how it's working. Give me 1 second. There's my first step, excuse me. There's my first step, and I'm putting in whatever this x scale is, but I'm not going to put in, I'm going to omit, not going to put in the pi symbol. If I get a decimal, I hit math, fraction, enter, enter. So here's 1 pi over 6. Okay, here's my second step. Oop, I got a decimal. I turn it, so this is 1 pi over 3. Here's my third step. Oop, I got a decimal. 1 pi over 2. I'm going to press pause. I want you to finish going 8 steps to the right and 4 steps to the left. And then so we've discussed how do we get this, and sometimes that's like the tedious stuff. Now, how am I going to use this? Pay close attention here. We're working with a sine function. So at my starting point is 0. The output is 0. 0 times the value up front. Well, 0 times anything is 0. Then I go to 1. Pay close attention. 1 times negative 2/3 is negative 2/3. Then go to step 2. The output for sine is 0. 0 times negative 2/3, well, 0 times anything is 0. Go to step 3. Negative 1 is the output for the sine. Negative 1 times negative 2/3, well, 2 negatives make a positive, which is positive 2/3. And finally, in step 4, we have an output of 0. 0 times any value is 0. Once you have one cycle, all you're going to do is you're going to mimic that. Like, you're going to keep that wave curve going. So I'm going down, back up to the highest point, and back again. Make sure that it's curved, and then it keeps going. And I'll go the same way here. Once you have one cycle, it just keeps going. Down, back up, and down. 2 cycles, you're going to see in your homework, it's going to say x max. That means 2 cycles, in this case, is a distance of 4 pi over 3. 1 cycle to the left, so x minimum for this particular graph is a distance of negative 2 pi over 3. That doesn't mean it stops here. It just means for seeing these 3 cycles, that's how far we go to the right, and this is how far we go to the left. All right, here we go. So let's start with amplitude. So this is our new function. This is example number 4. We're going to do 5 examples in this recap of learning. So for this particular function, I'm always looking at what's in front of the function to determine the amplitude. So the absolute value of positive 2 is just 2. That means I'm going to go 2 up and 2 down from the midline. 2 up and 2 down from the midline. My wave curve is going to be cut at half at the midline always. Period length. Now this gets tricky. Look at this. I want to rewrite this. This is the same as 1/4 times x. So this is like y equals 2 sine of 1/4 x. That's the same as this. That's the same as this. So how do I figure out the period? We always take 2 pi and we divide it by 2 pi divided by whatever is the b value. That's the value in front of the x. In this case, it's 1/4 that's stuck in front of the x, divided by 1/4. So 2 pi over 1, stay, change, flip. And I end up with 8 pi over 1, which is the same as 8 pi. This is going to be the easiest one for us to number. That means that the period means after you do 4 steps, on the 4th step, you're landing on this value for sine and cosine. After 4 steps, this is where you're landing. Now, how do we figure out x scale? X scale is always take whatever the period is, and we're always going to divide it by 4 because there's 4 steps in sine and cosine. So 8 pi divided by 4 is 2 pi. Now, this is going to be nice. So each one of these is a difference of 2 pi. So like 2 pi plus 2 pi is 4 pi, plus 2 pi is 6 pi, and I'm going to keep going. Here's step 5, 6, 7, and 8. 10 pi, 12 pi. And then we're going to reverse course here, going to the left. Negative, make sure to include those negatives. Easy enough. What's the next thing we're going to do? Well, we need to graph this. We're working with the sine function. So I start at the starting point, the output is 0. 0 times any value is 0. Okay, let's go to the next one. Okay, we're on step 1. We have an output value of 1. 1 times 2 is 2. Go to step 2, the output value is 0. 0 times 2 is 0. Go to step 3, we're at negative 1. Negative 1 times 2 is negative 2. And lastly is 0. 0 times 2 is 0. Okay, remember, we're not making a V. This is going to be that kind of a nice curve. That's one cycle. And once you do one cycle, you're just continue. So I'm going up, back down, low, back down. It's going to be that same shape. It's like you're just duplicating it, and you keep the arrow going. And we're going to duplicate it over here to the left. If somebody asked us what is the x maximum for this graph, that means 2 cycles out to the right, it'd be 16 pi. If somebody said what is the x minimum for this graph, it'd be 1 cycle to the left, which would be negative 8 pi. We are working right now on our last example, and so I'm going to try to go through this a little bit quicker. So here's the first thing. Whenever you see a plus or minus in back here, it's not in parentheses. That tells you that our midline is changing. We are going to go up 2. So we're going to go up 2, and now I'm making a new dotted line. This is like the new x-axis. We have just shifted this entire graph up 2. I had taken care of that. Everything else will remain the same, but this is like our new x-axis, okay? Everything's been shifted up too. So when I look at the amplitude, I look like directly what's in front. And we go, what's the absolute value of negative 1? It is positive 1. So from here, because this is like our new origin, where the x-axis has been moved up, I'm going to go up 1 from here and down 1. So 1, 2, 3. I'm going to go as high as 3 and as low as 1 because it's going to be above and below that new midline. 1 above, 1 below. How do I figure out the period? I'm taking 2 pi and dividing it by whatever is directly in front of the x and behind the function. So 2 pi divided by 2 pi is 1. So the period length is 1. That means after 4 steps, we're at 1. How do we find out the x scale? Take whatever the period is and divide it by 4. And at this point, you've learned we're going to take this, and we're going to take 2 times 1/4, right? 3 times 1/4, and so on. So I'm going to go ahead here, and just for the purpose of time, I'm going to go ahead and write these down. So I have 1/4. Now we're going to go on to 1.25. Oops, sorry. Forget about that. And then we're at 3/2. And then I'm at, what am I at over here? I'm at 1.75. What is 1.75 back to my fraction? Is it 7/4? And we're at 7/4. Okay. Notice that there is no pi symbol. It's like I automatically my brain says we need to throw that in, and you're thinking, why is there no longer a pi symbol? And the reason for it is because they were eliminated. 2 pi divided by 2 pi, well, the pi's cancel, and the 2's are going to be simplified into 1. All right, it's time to start graphing this. This is my origin. We'll be done here in 30 seconds. Are you ready? Here we go. So I'm working with the sign. So the starting point is 0. 0 times negative 1 is 0. That's my origin. Step 1, the output is 1 for sine. 1 times negative 1 is negative 1. So go to step 1 and go down 1 from my midline. Go to step 2, the output is 0. 0 times negative 1 is 0. Go to step 3, the output is negative 1. Bless you. Negative 1 times negative 1 is 1. So at step 3, I'm up 1. And you can see here when I go to step 4, I have 0 again. 0 times negative 1 is 0. We see this basic shape here, and then we just need to continue it. So it's down, midline, up, midline. And the same thing over here. Up, midline, down, midline. We have a max in this graph of 2 and a minimum x value of negative 1.